Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are Team 1 from Group NBCS 1435A. We are here today to talk about how to apply linear algebra in an electric circuit. This presentation explains the use of linear algebra in an electric circuit, establish method to solve the electric circuit such as Thevenin's theorem, and mesh analysis will be used. The outcome of the solved electric circuit will be a system of linear equation that solution can be found using metric that we studied from linear algebra. The objective of the presentation is to show that we can solve unknown variables of a system of linear equation using metric that we learned in MAT263 Linear Algebra 1.
So, from the objective, we are using reduced raw echelon form. The electric circuit in figure 1 is a resistor inductor RL circuit, which consists of 500 mH inductor L1, 2 ohm resistor R1, 4 ohm resistor R2, and a current control voltage source V1. The control the current control voltage source V1 is controlled by the current I that passes through the inductor L1 as shown by the arrows. The circuit in figure 1 asks to find the value of time constant t, where t equal to L over RT. The L is the value of the inductor L1 in unit Henry H, and RT is the value of total resistance of the current in unit ohm, as seen from the inductor L1. Assuming at time t equal to 0 second, the initial current that passes through the inductor L1 is I. The time constant T is the time taken for the initial current I to deteriorate to 36.8% of its initial value I. To solve the problem for time constant T, we need to find the value of inductor L and the total resistance RT of the electric circuit in figure 1. We can easily find the value of L, which is 500 mH or 0.5 H of inductor L1. But to find the value of total resistance RT of the circuit, we will use the following Thevenin theorem method. We are using two method yet. That's Thevenin theorem method and mesh analysis and reduce raw echelon form. Method 1 is a Thevenin theorem. Remove the indicator L1 and replace with a direct current DC voltage supply source of 1 volt as shown in figure 2. The 1 volt DC voltage source is added because there is a dependent voltage source exists. Example, the current control voltage source V1. The voltage across the current control voltage source V1 is 3 ampere, where is I is the current value in ampere A. Method 2, mesh analysis. Using the mesh analysis adopts Kirchhoff voltage law KVL. From figure 3, there are two loops mesh of KVL. Example, mesh 1 and mesh 2.
Okay, so mesh one, if we look at the left side of the circuit, so taking that clockwise, okay. So if you we start from below of the circuit under the mesh one on the left side of the circuit, so you will see the power supply. So why? So the power supply start with a negative voltage. So that's why, and the voltage is 1 volt. So we have minus one. Minus one means minus 1 volt starting from below. Okay. Then moving clockwise, we see a 2 ohm resistor. Because you see there are two current. This is because we're using mesh analysis. So you have two current, so I1 and I2, and they are in opposite direction. So that's why we have to multiply by I1 minus I2. And then we simplify the equation. So we will get 2I1 minus 2I2 equal to 1. Now, if we look at the right hand side of the circuit, again using mesh analysis, uh, again we using clockwise. Okay. Now I2 is the main current, the domain I2. So now you see we start from 2 ohm resistor. Okay. Now since I2 is the main current in on the right side of the circuit, so that's why we have two. That's the resistor. You have two current flow through that resistor in opposite direction, I2 and I1. So that's why we have two I2 multiplied by I2 minus I1 because of the mesh analysis. And then then the next one you have 4 ohm resistor. And this 4 ohm resistor only one current flow through, that is the I2. So that's why we have 4 I2. And then we have the uh, current control voltage source. This current control voltage source referred to as voltage dependent. Okay. So since this voltage source, the voltage depend on current, and how to find the voltage? We multiply three. You see the value there, 3 ohm. That 3 multiplied by I is the current that flow through the power source. Okay. If you look at the circuit, this I, the current that flow through the uh, 1 volt power supply, is opposite direction to the I1. So that's why I equal to minus I1. Okay. Now, if we simplify this equation, we will get 2 multiplied by I2 minus I1 plus 4I1 minus 3I1. And then we simplify that, we will get the equation 2. Okay, now we already have two linear equation, equation number 1 and equation number 2. So what we do, we can form augmented matrix. And you can see below the augmented matrix, which consists of 2 minus 2 minus 5 6 and 1 0. And there are many methods to solve this problem. Either we use the what we call that Gaussian elimination method, or we can use the inverse matrix, or we can use the Cramer rule. But I prefer uh, to use this reduced row echelon form. Okay. So 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 you can see on that augmented matrix, from the augmented matrix below. So what we do, we multiply 0.5 to the first row. Okay, and we get 1 minus 1 minus 5 6 0.5 and 0. Next, what we do, we multiply 5 to the first row and we add to the second row, and then we change the second row. So we get 1 minus 1 0 1 0.5 and 2.5. So then finally, what we do, we because we are using the reduced row echelon form technique, so we add row 1 and row 2, so we get 1 0 0 1 3 and 2.5. So I1 value is 3 ampere and I2 value is 245. But in this case, we don't require I2. What we need is the I1, that is 3 ampere. Now, we know the voltage source is 1 volt, and we know I1 is 3 amp now. So what we do, we use Ohm's law. We find the total resistance of the circuit, okay, the Thevenin circuit. So you're using Ohm's law, R equal to V divided by I, 1 volt divided by 3 ampere, we get 1 over 3 ohm. And then from the time constant equation, tau equal to L over R total. So we know that L is 0.5 Henry, and we know the resistor is 1.3. So 0.5 divided by 1 over 3, not 1.3, 1 over 3, one third. So we get 1.5 second. So the time constant for the circuit is 1.5 second. Okay, so we see that even though we are using just now Thevenin using mesh analysis, but we to solve this problem we require linear algebra, that is used in this case using reduced row echelon form. Okay, not to ensure that the our calculation is correct, that is I1 equal to 3 ampere. So that I mean to confirm, so either we can use a calculator, kan, to, we use the linear equation mode, or we can use this software, okay, this electronic software, okay. So this type of software, okay, where you can create a diagram, electric circuit diagram, and okay, and then you can check the current flow, okay, from this application. Okay, okay. So conclusion. Either you use linear algebra, okay, so linear algebra where you learn about how to derive formula, to prove, to show the formula, prove the formula, and also you learn how to calculate. But in engineering, like learning electric circuit, uh, most of the time they apply the formula. And today, of course, you have many application, example like multi-sim, which you can directly uh, find the value of the current, and then you know what the value of the voltage, and you can find the resistance of the circuit. But linear algebra is more challenging because we are learning real mathematics.
The reference that we use for this presentation is from Elementary Linear Algebra by Habens Kochima and Fundamental of Electric Circuits, sixth edition from by Charles Alexander and MAT263. That's all from us. Thank you.